Hello and welcome to my talk about mental models in astronomy, and I'm very pleased to be here today. Thanks for the invitation to Professor Roland. And today I'm just going to talk about some of the research we are doing here in Germany in Münster, and also some general stuff just to lay out a bit what exactly are mental models, why are they important in education, and yeah, what research is done on them. The aims of my talk today are first to give you a bit of an insight into what mental models really mean for the foundation of learning, like what's their thing, what's the deal with them, and then together with that, I want to give some insights as well into the current research about the mental models in astronomy. And it is actually not that much that we know there, but in other areas of physics education, we know a lot. And therefore, yeah, I hope that I give you some new information there today. Also, something I will do in the end is talk about mental models of black holes that we do research on, because there's not a lot of research done in that topic, and we hope to yeah, lay some foundations there as well. So let's start with what is a mental model, what are mental models, and why are they important? Um, First thing to know is that every learner that goes into a classroom or into any learning environment has mental models. They bring them with them into the classroom, and it's like their worldview, like the way they view and frame the world. That's what their mental models are. Um, they are created via the interplay of new experiences, past experiences. So if you learn something new, you perhaps adapt your mental models, you create new ones in your head, and they are therefore a tool for learning and understanding. And yeah, also an interesting thing that I always find is that mental models are used economically, so to speak. So if you have several models of certain phenomena, you always use the one that's easiest to understand and that still works. So that's why I wrote down economically here. So that's something I find very fascinating, and I think you should always keep that in mind, because in some studies there are some problems apparently that people use different mental models for different contexts, and one of the reasons is just that you always use the model that's easiest but that still works. So yeah, there are two core aspects to mental models, at least in the line of work where I am. And those are the two components, gestalt and functionality. And what does that mean? What does that mean that a mental model has those two components? And I have presented here a cake, an astronomy cake, and I want to illustrate what I mean by looking at this cake. So first, the gestalt of a mental model. The mental model you now have of this cake here on the screen is yeah, it's blue. It's a cake. There are planets on it. There's a little telescope on top, and if you would have it in front of you, you might smell its smell. It might smell very, very pleasant, and you might yeah, enjoy that as well. So that's the gestalt. So it's everything, like all the modalities, all your senses can get. Like, what does something smell like that you or what does something look like, or what does it taste like or feel like? So all these sensual impressions together are the gestalt of the mental model. And if you think of something, you mostly think of images, sometimes you think of sounds, but all of them are theoretically possible. So you might think of a smell as well. And the second component is the functionality, and that one's a bit more difficult. It's like what does the mental model represent? What does it mean? What does it signify in Piaget's terms? Or what can it be used for? Like in this, if you have now again this mental model of this cake, you might ask yourself, what does that mean? It might mean that, oh, I'm hungry for cake. I want to eat that cake. Or if you've just eaten, it might mean that imagining this cake is like, oh no, I don't want to eat right now. I'm like stuffed. It's not no use to eat it. Or perhaps if you're angry at someone, then the mental model of the cake is something you can throw. You know what I mean? It's a bit more deep. It's like what it signifies. And those two components are what make up mental models, and they are rooted in neurology, actually, which was at least hints to that were shown by Levy and Srinivasan. Those two are split brain forces, and they found that there are, I'm not going to go too deep into this, there are two areas that the brain works in, so to speak. It's a functional area, so you match things by function or by appearance, depending on where you look in the brain or which brain parts you use. And here again, illustrated is what does Gestalt mean, or appearance as it is called here in this paper. It's like, yeah, it looks the same. You see the sunglasses look like the yarn, the scissors look like the spoon and the fork and so on. And matched by function is like, yeah, it shields you. The sunglasses and the sun shield you against the sun. The scissors and the yarn are for sewing, and yeah, the cake and the fork and the spoon are for eating. You know, that's again the same idea, but it's like a brain functionality. So mental models are probably produced by these two brain areas that were at least conducted research on here. That research was conducted on here, and so that's the basics. That's a mental model, and that's what we look at here. And why do we even care? Because mental models are the tools learners use to understand the world. So a mental model is what I use to make sense of the world. And so if we know what mental models are that learners might have, we know something about their grade of understanding. Like if they come with a very simple mental model, we know, okay, they're perhaps novices. If they come with an elaborated one, we know, okay, they are perhaps almost experts already. Mental models are all individual, I mean, by nature, but there are commonalities between them, and we can actually look for these commonalities, we can catalog them, and we can write them down so that teachers might have an idea what types of mental models they might encounter. And I will talk about some of them later. And also something very, very, very important, and that's my main area of research actually, that mental models are something that students take too literally. So if I think of, I don't know, if I think about an atom and it's like a little, I don't know, nucleus and there are electrons circling around it, I think that's what an electron looks like because my model is like that, my mental model is like that. But no, that's not the case. I mean, it's just trying, that image is just trying to describe what an atom does, what properties it has, but what it looks like it doesn't really describe. And yeah, that's very, very, very important because every teaching material teachers give to students, children, or young adults or whomever, they all have mostly pictures or whatever. And in most instances, the first thing is that they take pictures literally. It doesn't matter who you ask. It might be very old people, it might be very young people. It's almost the same for everyone. The first time you think is, okay, that's how it looks like. And that's a very, very big danger in this area of research. So it's pretty good to know about mental models, what kinds there are, and what perhaps what models that you would call misconceptions were found as well. So you understand where are misconceptions perhaps that are expressed through the mental models the students talk with, or however you say it. And as we are in astronomy today, fortunately because I love astronomy, what are typical mental models in astronomy? And I'm only going to list some ones you might call misconceptions. So the first one is the Earth is the center of the solar system. That is a pretty old misconception, I would say. I mean, we've known for a long time that it's actually the other way around. The sun is the center of the solar system. But it might be a mental model where they have Earth in the center and everything revolves around it. So that might be a mental model here, and they found that, and that's a mental model that young students mainly have. This one is a bit more, this one is a bit more often found. It's all planets are roughly the same size, and they're all the same size as the sun approximately, and that's this type of mental model, if you imagine like that, that's probably because of textbooks and media. Because in media and textbooks, planets all have the same size on the side, roughly, so they all fit on it. And also the distances are not like very, very close together. They're not close together, but in the textbook they are. So these kinds of mental models might develop from that, and they probably do. Planets move on strings. Yeah, you see the solar system, and there are these the orbits and they are drawn with a line, and the planets are on these lines, and they move along these lines. And you could now say, why would anyone think there are real strings in space? Who would think that? And actually Kepler did, and others do as well. It's like, again, this literal interpretation of the picture that you see or the mental model you have. So obviously the strings or the lines in the solar system, they just want to tell you where it moves, where the planets move. So yeah, that's a misconception we found as well, or people found as well. And this one, I like this one a lot. All stars have jacks. Yeah, you know, they are like these little pointy things that you draw as a child, and people think they really look like that. So these are typical mental models in astronomy. And I now want to illustrate how you get to know about these models. And what we do is we ask the learners. I mean, that's the best thing to do here. So we ask the learners, what do you imagine? How do you think about it? Or what images do you have in your head? And we do that through questionnaires or interviews, or we might like videotape some discussions, or we might do similar stuff. And that's basically how we get our information. And now to the topic of black holes, because that's what I promised as well. I want to tell you about how we went about on collecting the mental models of black holes. And first, we just focused on the Gestalt part. So we just focused on what do people think of, what images do they have in their head when they hear the word black hole. And for that, we asked 26 astronomy novices, so they never had an astronomy course. And we wanted them to draw black holes from the top and from the side. Why from the side? Because the top is probably like a circle that's black, like the image we all know. But what's from the side? How do they imagine that? And that's the interesting part, because we thought, yeah, they might imagine different shapes. So let's see what the people drew. So this is one of the things. Sorry for the German labeling, I didn't change that. So this is like something like a disk. You know, the black hole is like a disk. It is round, but from the side it's like very flat. Or it might be a funnel. So you have again this round thing, and then you have a funnel going inwards. So that's the black hole perhaps. Or perhaps it's just a sphere. It's spherical from every direction. Who knows? That's what the people drew. So what do we do now? We just take the pictures, and we just count how many pictures the participants drew that were alike. And there were many people, and almost everyone, I would say, they drew first the circle with the black inside that you saw on the previous slide, like this circle here, or this circle. They all drew that in the top view, everyone. Some drew an oval shape, you know, because perhaps they couldn't draw that well. I don't know, I couldn't draw that well. So yeah, but the interesting part was the side. So the side was only 4 drew a circle from the side, so it would be a sphere then, or an oval, it would be an ellipsoid then. But also 6 drew a funnel-like structure, and 2 drew something like a cylindrical structure, which in the end we also added to the funnel because it was also funnel-like a bit. And then 4 drew a line, so that would also be a disk. And we intercoded that, and we had extremely high matching. So our sorting of the pictures was pretty on, like in line with the other people that did it in our group. So it was pretty good results. And we created this from the drawings, the initial drawings. So we have this ellipsoid, we've got a sphere, we've got a disk, and a funnel. And what do you do now? We wanted to see if this is really everything. So we gave these to people and told them, yeah, could you please choose what a black hole looks like? And we also had the option, none of the above, because we didn't want them to only be confined to these 4 answers. And this was the result. We did this with 50 students, also non-physics students. They never heard anything about astronomy. And the distribution is a bit different here. So we only have 3 left that drew oval, that picked the oval shape. So like an ellipsoid. Almost no one thought that anymore. 20 drew the line, picked the line. So 20 people were having the mental model of disk when they think of a black hole. 13 were having a sphere, and 14 a funnel. So you might ask, why is it so different to this one? why did this oval shape disappear? And what we think happened is that this one here, this view was interpreted as a disk when they, or not interpreted, when they drew something like this. They wanted to draw a disk, but they were too afraid to draw something like this because it was too extreme. So they like drew a top view a bit. And that's our explanation, but we're not completely sure. We have to do more research on that part. And it might have been the drawing skills. So if we do this with more people, we would have more reliable data, but this is okay as well. So we had 50 people, so it was about a third. Like the line, okay, a bit, some more people chose the disk, but it was about evenly matched between sphere, disk, and funnel. So that was the result we got. And where do these images come from, you might ask? And we just we think it's probably from like science fiction movies, media, stuff like that. These are pictures I looked for because these are, or these I took because they are like the three shapes we just said. So this is a sphere, this is a disk, and this is a funnel, so it goes down. So yeah, so we think that's probably where they get their models from. So, and the last part I want to do is we also asked them to describe black holes, and from these answers we try to see whether we had like like different stages of understanding of a black hole. And we took some previously known literature in other parts of physics education to like sort this a bit, but I will just give you the results, the general results we found, those general stages. So the first stages, people didn't know what it is. They did not have a real mental model of a black hole. They say, yeah, I don't know at all, but it's probably not a black hole. I don't have any idea. So that's the start. And then you perhaps get an image, you form an image in your head, and then you say, okay, black holes are black. I know that. So that's the first step in the mental model development. And then they might think about, what does it do? Okay, it might track things, it might grow, it might shrink, I don't know. So then they say stuff like this: a hole in the sky that's capable of making stars disappear. It also absorbs part of space debris. So that might be one of the more developed mental model types. And this one is still focused on this image of a hole in the sky. So if you take this image and you let go of that, you say, okay, I didn't really care how it looks. I just want to see what it does. Perhaps describe it with formula, perhaps describe it with words. I don't know. And then someone might say something like, and they did say this, because of the property of sucking in matter, the designation hole actually fits quite well. So it's like an abstract concept of a black hole. And that's the thing, that's probably the most advanced mental model we found. Something that's just a very abstract concept. So not many people got there, but yeah. So, and now I'm at the end of the talk already. So just short conclusion, because I'm a bit over time. What did we learn here? It's very important to know your learner's mental models to help determine what level of understanding they are on, or what misconceptions they have. So if you know what general mental models there are in certain areas of physics education or astronomy or whatever, you might be able to more precisely determine what misconceptions are at hand, or what problems they have, or how deep they understood the topic. Also, what I want to emphasize is that yes, you can, obviously you should use images, depictions, and textbooks and perhaps media, but always think about how accurate are they, and is it important how the things look, or is it more what they do, like what is the abstract meaning of the picture. And I think it's important for teachers to do that as well with students, to like reflect on the pictures they see. And yeah, the last thing is, yes, it is necessary. You have, or you should, at least that's from my experience, you should give students images so they can start developing their mental models, images or sounds or whatever. I mean, in music education, you probably give them sounds, but yeah. So you first give them images, you let them play with them, you will let them imagine, and then you one day perhaps get to an abstract meeting. And that's all from my talk, and thank you for listening to it, and I'm looking forward to the others.